Hi, this is Empowering Introductory Algebra, the series created to assist students to overcome any basic algebra deficiencies and build a strong foundation leading to those college-level studies. Hi, I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. With the help of the BCC crew, we will bring you introductory algebra lessons like no other. Let's pick up where we left off and we'll show you why. Now, in the last episode, we were talking about perfect squares. Now, what makes a number a perfect square? Well, if you take something and raise it to the second power, or take that item and times it by itself, you get a perfect square. And a perfect square variable we talked about was divisible by 2. The exponents or powers were divisible by 2. So having that understanding of perfect squares is going to help us factor in the next episode now, which we're going to call special factoring. Let's go to the first graphic here. And when we talk about special factoring, we're going to start with the trinomial square. And the trinomial square usually factors into two of the same things. So I've got the general format for most trinomial squares. The first one, a squared plus 2ab plus b squared, will always factor, notice, into a plus b times a plus b. And if we write that sophisticatedly in algebra, we can call that a plus b quantity squared. And the second trinomial, a square minus 2ab plus b square, factors into two of the same things. Notice 2a minus b's, or a minus b quantity squared. So let's go to some examples here, which are really some more notes I started out with. So in the special factoring problems, trinomial squares, here's how to recognize them. And they're pretty easy to. The first and last terms are perfect squares. Okay, that's the first step, to be a trinomial square. Step 2, there must be no minus signs before the a square or b square in that general form we went over. So notice on these last two, there are no minus signs before the a square or the b square. And part 3, when we go to check these, if we multiply a times b and double the result, we get that middle term. And we'll see why that works now here in a second. So let's go to some examples, all right, with trinomial squares. So the first one, notice, we've got x squared and 9. So the first and last terms are indeed perfect squares. Now we could do our rainbows on this, of course. Rainbows always work, but these are even faster than rainbows, believe it or not, if you see that first and last term as perfect squares, because when we go to break them apart now, what two of the same the first two terms, what two of the same things will give me x squared? Xx. And since both of these signs are pluses, both of these signs will be pluses. We've seen that in the past. And what times what same two things gives me 9? 3, 3. So very nice to factor here. And notice if I take a and b, a is x and that's 3 there. If I multiply those and double it, I get 6x in the middle. Or if I were to FOIL this, I would get 3x on the outside, 3x on the inside, and that would give me the middle term. So it will check by FOILing or plugging numbers in to show the factors work. All right, second example, again, notice this format. First and last terms are perfect squares, so if you look for that first, we can go ahead and see if we can get two of the same things out of that. What two of the same things multiplies to give me the first term? 16x squared? 4x, 4x. All right, now both signs have to be the same here as well. They either have to be both pluses or both minuses. So in this case, since we have a plus on the end and a minus in the middle, I think we're going to have to go with minus minus there. And then what to get the 25? 5, 5. And again, we can write both of these answers sophisticatedly. Like when you look in your algebra book, this first one might say x plus 3 quantity squared because there's two of them. Or this one might say 4x minus 5 quantity squared. So these are special factoring trinomial square problems. Very quick to do, aren't they? I like these versus some of the others. All right, now let's look at some more. And some of you are going, oh, he's turning up the heat again. Yes, he is. You know he will here. So anything in common here? Again, the first and foremost rule of factoring is to always look to take something in common out. Is there a common number of 9, 48, and 64? I don't think so. Okay, there's no x's I can take out of each one. There's no y's, but if I look at this, the first and last terms are what? Perfect squares. Perfect squares. So when I break them up, I'll get two of the same things. What times what gives me the 9x to the 8th? Well, 3 to get the 9. X to the what powers? 4th. Because whenever you multiply same bases, you add the powers. So the first two terms would be 3x to the 4th. Both signs pluses or both signs minuses in here? Well, it would have to be plus plus here, plus plus here. And to get the last two terms to give me the 64y to the 6th, it would have to be 8 to get the 64. And what? Y cubed. That one's such a large answer, I had to crunch it in there. So there is your factored answer. And if we wrote it sophisticatedly, we could write 3x to the 4th power plus 8y cubed, quantity squared. So most of these, look what's happened. We have a trinomial square that factors into, guess what? A binomial squared. How about that? In those last several examples, we have a trinomial square starting out, binomial squared for the answer. What comes around in algebra goes around. Hot dang. Now, some of you are going, not fractions, Young. No, not fractions. Don't panic. All right, notice the first and last terms. It's trinomial square time. All right, so fractions, I'm going to make a little bit larger parentheses on this one to fit them all in. Fractions work the same way. What two of the same first terms will give me a 36 over 49th, a to the 12th? And notice that perfect square fractions contain what kind of numbers? Those perfect square numbers we talked about. So this would be 6/7 times 6/7 would give me the 36 49ths. A what? A what? A to the 6th times a to the 6th will multiply to give me a to the 12th using power rule 1. How about the signs here out there? Y'all caught on enough yet? Both pluses or both minus signs here, looking at these two? I think they're both going to have to be minuses to get a plus on the end and that minus back in the middle when I FOIL this back. All right, and to get these last two terms to give me this one, to get 1/4, 1/2 times 1/2, b squared. So this would be the factored answer, and you could write it quantity squared over there if you wanted to. Yeah. Now some people might look at this and say, Young, how do you know this checks? Well, make sure you get this middle term here. I know with fractions some of you get scared, but if you were to multiply these, we can do it. 6/7 times a negative 1/2 would give you, if you cross chopped here, a negative 3/7 a to the 6 b squared. Negative 3/7. That might be a little hard to see there. And the bottom one would also be a negative 3/7 a6b squared. And notice we'd take negative 3/7 and negative 3/7. It would check to give us that negative 6/7 back in the middle. So don't be afraid of diffractions. Now, trinomial squares, let me get that straightened up a little bit. Be careful. All right, it's the be careful time again. Now, some of you out there look at this and say, hey, Young, hey, we got a perfect square here. We got the first and last terms are perfect squares, but before you fall into that trap, and if you do, if you just start breaking that apart, you're going to hear, oh, you're going to be in trouble, all right, because there is a common number I can take out of each term. A common number that goes into 36, 96, and 64 first, and you must always first take out that greatest common factor. So what is it? Well, let's see here. How about a 4? I think 4 goes into each one of these. All right, so when we take the 4 out, and if you want to, we can go ahead and put it underneath each term, if that helps you, the greatest common factor, we get 9a squared plus 24ab plus 16b squared. And look what's left here. Oop, there it is. A trinomial square left. So sometimes you can take it out. Now, Young, what if I would have gone up here and just started factoring that without taking out the 4? Let's see what would have happened. And I'll show you real quick here. Let me sneak up here and said if we would have done that, to get 36a squared, y'all would have said 6a, 6a, right? To get the 64b squared on the end, you would have said plus 8b plus 8b, right? And this would FOIL back to give you this. Now, what's wrong with this answer? Notice inside the parentheses what? There's something in common we could still take out. So this is not considered completely factored, all right? So make sure, remember we talked about this earlier in the previous lessons, if there's a common number left in any of those parentheses, using some deep doo-doo. So be very careful there's nothing left in common here. That would not be considered completely factored, because you can see there's some things that come out, and actually in each one, a 2 would come out of each one, and then you'd end up with a 4 out here anyway. All right, so it would come out in the wash. Once you factored it wrong, you would catch it and say, hey, there's still some more stuff to pull out, and you would get to here. All right, so now let's go ahead, break that apart into 2 of the same things, and we'll be merrily on our way here. What times what gives me the 9a squared? 3a, 3a. Both signs pluses or both signs minuses, the plus plus. What? To get 16b squared? 4b, 4b. And notice in the parentheses now, there's nothing else in common, so I can feel the power. All right, and I could write this sophisticatedly as 4 times 3a plus 4b quantity squared. Yeah, so these are some be careful trinomial squares here. All right, so we've seen some characteristics here. Now, one other be careful number 2. How does he do it? Be careful 1 and be careful 2. Not everything that looks like a trinomial square is 1. Because on this example, well, gee, Young, you got that first and last terms, it's perfect squares. But if I go to break this up, watch what happens. I get 2x minus 3y, 3y. Does that check? No, because if I go to multiply this back, I get 2 times 3, a minus 3 out here would give me a minus 6xy. Minus 6xy, that's not going to give me a minus 20 here anyway. And actually, I probably should make that a 20xy there. Let me go ahead and sneak that y in the problem. So that one is not going to give me this back. It looks like a trinomial square, but you know what they say, looks are deceiving. So how would we factor this thing, Young? All right, it's not a perfect square trinomial. It doesn't give us 2 of the same things. Well, don't forget what always works. Somewhere over the rainbow. We can get those skies again nice. All right, 4 times 9, 36. Factors of 36 that will add to give me 20 in the middle, you would find minus 2, minus 18 once you get good. And I tell you, the more you practice this rainbow technique here, boy, you will get surprised how quickly you can get those numbers, because they seem to like go round and round. All right, so now we can come down here and we can say to get 4x squared, we could either have 4x and x, but we know that 4 times nothing here is going to give me one of those. So we'll go 2x, 2x. All right, and now we can force those rainbow numbers. 2 times what gives me the minus 2? We'll put minus 1y there since there's a y on the end. So we've got our minus 2 on the top rainbow. And then this will give us, what will give us minus 18? 2 times what in here will give us the minus 18 will be minus 9y. See, so in this case, it looked like it was a trinomial square, but when we factored it, we didn't get 2 of the same thing. So be careful. Be careful. All right, let's go to some more avenues for help here. Now, this is the time of the segment. We always like to give you those study tips and avenues for help. And avenue for help number 7 is don't get too much help. You know, sometimes students try to overdo it. Don't sit, watch, and nod as instructors or tutors or friends work problems for you. A good tutor will demonstrate the concept, but once you understand it, you have to practice it many times to become proficient yourself. Remember, once you sit down to take that test, folks, you are on your own. So do not forget that one. I have a lot of students, boy, they'll come in there and I'll work problem after problem for them in the office, and they'll be sitting there, yeah, I got that, yeah, I got that. And they don't go home and practice it, and then they get to the test and go, but I had that, Mr. Young. But until you do at least 4 or 5 like that, you got to sink it in. It's got to sink in there. So make sure you spend enough time outside of class. Remember, we said for every 1 hour in class, 2-3 hours outside of class. And I was speaking to one of the film folks earlier. I said math is a whole bunch of 4-letter words. One of them is work. All right, and there's several other ones. Time, work, time. These are things that make you successful in math. And then a couple of them gave me some other four-letter words that I won't talk about here on the air, so we'll leave it at that. All right, go on to the next graphic. We're going to do some more special factoring here, and the next category of special factoring is what is called the difference of two perfect squares. And these usually factor into conjugate pairs. And I want you to write that word down, conjugates. C-O-N-J-U-G-A-T-E, conjugate pairs. The conjugates are going to be your friend, believe it or not, later on in the course. All right, now what makes something the difference? Remember what that word difference meant from way back? It means subtract, and you're going to have some perfect squares subtracting there. So a square minus b square will factor into a plus b times a minus b, and that is called conjugates. All right, so let's go to some examples there and we'll look at them. All right, so notice I wrote easy to recognize these difference of two squares. One, you always got the difference sign between them. And then two, you always got the two perfect squares. Now this is a little different than the trinomial square because when you break them apart, watch what happens. The first two terms to get 4x squared will be 2x, 2x. Now to get the minus 9, so you can't put plus plus or minus minus in here, so you won't get two of the same things. To get a minus 9, the signs must be opposites, right? Because then you can put plus 3 times a negative 3 will multiply to give you that back. So notice on these conjugates, the O and the I part of FOIL go out. So I have a little saying on these whenever I multiply together or whatever. Remember when we were multiplying these and foiling these way back, we said FOIL went to Florida? That's what happens there. We just multiplied the first two and the last two to check that, if you remember in previous lessons. All right, next example of difference of two perfect squares. Break that apart. To get 25a squared, the first two terms, what times what gives me that? 5a times 5a, which I like lots of a's in my classes. Signs, plus minus, to get that minus there. And to get the 16b squared, 4b, 4b. Now, obviously, we can't write 5a plus 4b quantity squared here. Why? Because, well, they're both not pluses. So these are what are called conjugates. Everything's the same except for one-term signs. Check that out. All right, but easy to recognize. Let's try some more. Oh, Young, not again. We just don't do the easy ones again here on the BCC network. We keep telling you, we bring it on. We bring it all on, fractions and decimals in one. Are you shaking? Are you going, Mama, Mama? Don't do that. We'll do it. All right, so go ahead and break this apart. To get 36 over 49, those nice perfect square numbers, even with fractions, it will come out 6/7, 6/7, C, C. All right, signs, plus, minus. And to get a 0.16, we haven't talked about perfect square decimals yet, but notice perfect square decimals are kind of like what numbers? There's those perfect square numbers again. So you will get plus 0.4d minus 0.4d. And if you multiply 0.4 times 0.4, you get the 0.16 back, d squared. So fits like a glove. Again, conjugates. All right. Now, how about this bottom one? A lot of you might say, Young, difference of squares, you could go ahead and start breaking them apart. And when I do the difference of squares, this is one of the rare times I don't put it in descending order. If it's, this one, if it's like this and you recognize the difference of squares, leave it alone. I don't even mess with descending order on these. I just kind of take them right on down the line. But there is a danger here. What? There is something in common, ladies and gentlemen. You can take a 9 out of each one of these. And remember, I tried to hit you with one of those early. Be careful. And if you take a 9 out, you can divide each term by 9, and you're left with 9 minus x squared, taking the 9 out. All right, now notice here, that is again the difference of two perfect squares. So I'm going to leave that 9 I factored out there and then get to the conjugates from here. So what times what gives me 9? 3, 3, plus, minus, what to get the x squared? X marks the spot. Yeah. Okay. So go ahead and leave those in numerical order. I like the way they break apart here, the conjugate pairs. Yeah. Now, what would have happened if I didn't take the 9 out first, and I would have come over here and made the mistake, I would have had 9 plus 3x times 9 minus 3x, and I bet you all see some things in common you can take out to get to this answer. Yeah, so be careful, there can be nothing in common in these parentheses. Yeah. All right, beware. You know, they say, this is pretty easy, but there are ones they try to trick you. How can I factor this? Is this the difference of two perfect squares? The word difference meaning what? That ain't no subtract. That's an addition sign. This is the sum of two perfect squares, and in the real number system, well, we can't really do this. We can't factor. Now, some of you say, dang it, Young, I'm going to factor that. I'll show you I can factor it. And you'll go x plus 3, 3. But when you FOIL that back, I'm going to say, look, the outside's plus 3x, the inside's plus 3x. Where's your 6x up here? And you'll go, dang it, Young, I'm going to factor that. I'll show you I can factor that thing. And you'll go x minus 3, 3. That gives you a plus 9 when I FOIL it back. I'll show you I can do this. But when you FOIL it, I'll say, hey, here's a minus 3x minus 3x. I'll say, where's your minus 6x? And then you'll say, I'm going to factor it, Young. I'll show you. And I'll go x plus 3, x minus 3. I'll put my conjugates, but I'll say, but when you FOIL that back, what kind of 9? Cannot factor that thing. People try. This is the most tricky thing in algebra. Cannot factor. There is no rule to factor the sum of two perfect squares, so beware. Now, would an instructor try to do that to you? Would you think some instructor would try? Oh, yeah, they would try. And they will smile and go, if they got you. So be very careful. All right, let's try some more. Now, some of you are going, wait a minute, Young, that's no difference of two squares. 2 is not a perfect square number, and 32, that's not a perfect square number. We're talking about the difference of two squares here, but don't forget that first and foremost rule of factoring out there, folks. That greatest common factor must come out first, which is a 2. So if you take a 2 out, what are we left with? A to the 4th minus 16. Now, it looks kind of harmless, doesn't it? It's like, all right, the difference of squares, now I see it. But this is another one where instructors will go, if you're not careful. Now, watch what happens. We can break that apart, and to get the a to the 4th, you all know it's going to be what times what? A squared, plus minus 4s. All right, and then you'll go on to the next problem on your merrily way, and the instructor that's been doing this in the background will now go, they're mine, I have them, and they'll go, wrong. And you'll get it back and go, but anyway, what happened here is when you factored the difference of squares, you have yet another difference of squares here. A squared minus 4 will still factor. And then some people will try to do this one, but we have found that if that's a plus sign, don't go there. That's a dark place. You don't want to go there. This one will not break apart, but this guy you must keep going on to completely factor. So another instructor favorite here, AA plus minus 2. So boy, look at this one. You got a lot of factors here in the bottom. Yeah, see, so when you factor these difference of squares, watch out. Watch out. They can happen more than one time as you do them. All right, let's go back to the graphic now, and let's just talk about, we've been factoring a lot here the last several lessons, and we're just going to go through the general rules for factoring, and there's 4 of them. All right, so I think the rest of the show here we'll just spend on reviewing and make sure we got some major concepts instilled in you. And number 1, always remember, and I know I've said this and you're going to get sick of me saying it, but this is the thing that I see that a lot of people miss. Get that GCF first when there is one, because if you don't, there will be things left in there to take out. And 2, when factoring 2 terms, binomials, look for those difference of 2 perfect squares. And when you get to the more advanced classes, you'll have the sum and difference of cubes to worry about as well. But right now, we're just going to worry about the basics, and then we'll build from that. All right, so let's review factoring 2 terms. All right, so you might get one that looks like this and say, hey, greatest common factor in there, and I can take a what out of each number here, a 4, and then how many x's will come out? Well, what do they have in common? It looks like 4 x's. So we could take 4x to the 4th out of each term, and when we see that greatest common factor, you can write it right underneath there and divide, and you'll end up with 2x minus 1. All right, and that is the factored answer. On the second example here, another greatest common factor comes out here. I could take a 2 out, not a lot, but watch what happens here. And when I take the 2 out and write it right underneath each thing, I get 25x squared minus 16. So I'm done, right? Be careful. No, you must start recognizing, I took a greatest common factor out, and there is the difference of squares. So you can factor that now into 5x plus minus 4s. And there is your conjugate pairs. Okay, so whenever you factor two terms, look for a greatest common factor and those difference of squares. Next graphic. Now, we have talked about this as well. When factoring trinomials, the easiest thing to look for is that trinomial square. First and last terms are perfect squares. You get two of the same things. Or remember, if a trinomial will factor, you can always use your rainbow numbers. The factors of a times c will always add to give you that middle number b, and if not, the polynomial won't factor or is prime. So let's look at a few of those in review. All right, so on this first trinomial, I see a common factor of a you can take out, and that'll leave you with a squared minus 18a plus 81. Am I done? No, because there is a trinomial square. All right, so first and last terms are perfect squares. Let's see if we can get two of the same things in here. A minus 9, 9. So that one factored into a times a minus 9 quantity squared. All right, so look for that trinomial square. Life is good. Now in this one, nothing in common. You can go ahead and do the outside numbers. 8 times 5 is 40. So somewhere over the rainbow. Notice I had them over here for that. Factors of 40 that will add to give me this minus 18 in the middle would be 2 and 20. It would be a minus 20 plus 2 would be the rainbow numbers. So we have learned this will factor into. Now we could try 8b and b here. It won't work. Can't get those rainbows. It would be 4b and 2b or not 2b. That is the question here. That will give me those rainbow numbers. 4 times what gives me one of these? Minus 5. 2 times what gives me the other one? Plus 2. All right, plus 1. So we have factored now 3 terms in review. And let's go to the next graphic here real quick and see if we can sneak it in here. When factoring 4 terms, remember to factor by grouping. Arrange it in descending order, break it apart into the 2 parentheses, and separate it with a plus sign. And let's go to that example real quick here and see if we can sneak it in before the end. I have it arranged in descending order. In this one, you can take an x out first, which will leave you with this. Then you can separate these 4 terms now that you've taken the greatest common factor out like this, and make sure you put the plus sign in there, and we'll wrap this one up when we come back in our next episode. So I'm not going to get it in, but we'll get it. In closing, practice the algebra concepts presented to master each lesson. Keep your work organized with problems copied and steps shown in detail. Read those related materials in your textbook. Work through similar examples and write down any key points to solidify your understanding. No one can do it for you, so take the initiative. It will pay dividends. I guarantee it. Take care, and we'll see you next time.